Greetings and welcome once again to my new calculus channel. My name is John Gabriel. So, what I'm going to do today is I'm going to show you very slowly how, for example, you can multiply two ratios. Okay, so remember, ratios are not numbers. Okay, so when people write something like 2 colon 3, it's actually a numeric ratio, not the primitive ratio, where you have an antecedent and consequent that are line segments. Now, why do I know what I'm talking about? Well, first of all, because I taught at the top schools in China. Let me tell you something very quickly because this is important for you to know. Parents trusted me with the teaching of their children because I'm brilliant and I know what I'm doing. And the best teachers at the schools I taught learned from me. And let me tell you, Chinese math teachers have eaten your lunch, your supper, and all your meals for the next 20 years. I mean, a 14-year-old Chinese kid knows more than a BSc graduate from Western universities. Am I serious? Yes. Maybe not everything, but what they understand is very deep. Okay. So, anyway, I was entrusted with teaching the little darlings. Good students, all of them, average IQs all above 140 because they're only children, they're spoilt, they come from rich backgrounds. So, but that doesn't matter because every human being has the same potential if taught using well formed concepts. And that is what I want to show you now is how you can actually, let's say, do a multiplication, by the way, which is just a division. Multiplication is defined in terms of division, not the other way around, like you've been taught by those incorrigible buffoons known as your math teachers or lecturers. They're highly stupid academics, shouldn't have even been allowed in a classroom, okay, ever. They have destroyed mathematics. They have destroyed your children's future. Now, I'm going to show you how you can multiply two ratios. Let's begin. So what you see in front of you here are a couple of lines. I'll explain to you what they are. So to understand a ratio, you need, for example, if I gave you this red line by itself without the blue line, you wouldn't be able to tell me anything about the properties of that line because you can't compare it to anything. So I'm giving it to you with another line which tells you what the characteristics of this line are in terms of the other line. Okay, so you need two parts of information for a ratio. And that's the reason, because if you just have one part, it's meaningless nonsense. I mean, you can draw as many lines as you like. They don't mean anything. Okay, they don't mean anything. So what I've done here is I've represented the red part as the antecedent and the blue part as the consequent. That's just done by convention, by the way. The consequent is normally what disambiguates the antecedent, okay? So the consequent disambiguates the antecedent. You begin to understand the antecedent through the consequent, okay, for both ratios, for this one and this one. And notice they're not the same, okay? Look, the red line's not the same and the blue line's not the same as the magenta line. They're two different ratios. How do we multiply these ratios? Well, it would first help to know how to divide them. So maybe I should divide the ratios first, okay? Let me do that. So now there are many ways we can do this provided they have the same consequent. Provided this, and this is the same, okay? So now to help me, because I've got a blank canvas here, I'm going to put a grid back on again, just the major grid lines, so I can see what I'm doing, okay? So here you go. So I'm going to show you first how to divide. Now, I want to divide this ratio by this ratio. I can either change this consequent to be the same length as that one, or this one to be the same length as this one, in which case the division will be straightforward. It'll just be the ratio of the new antecedent to the old antecedent, or vice versa. Okay? So now suppose that we want to change this consequent to this one. Well, how do we do it? We join these two spots, these two dots like that, and then we find a line that's parallel to this, okay? Like I'm doing now. So like that. Okay. And then we move this line parallel like that, and we go place it right on top there like so. Okay. Make sure that's on. And then where it meets this axis here is the new antecedent of this ratio on the right, of the green magenta, okay? So we want to know what that antecedent is. Very easy. We just do a little segment like that, and we see now what that segment is, and that segment is this L, I think. Okay. So I hate it. I hate it when it does that because it could be I or L. So I rename it to LL, and that's pretty much it. Okay. So now the new ratio will be this entire red line. Okay, this entire red line to this green line, and we draw the red line. I mean to this black line, and we draw the red line to this little black line. Okay, let's see what their values are. Now we don't. To see what their values are in geometry, we would have to find a common consequent, and that's not hard to do, as I'll show you after I've shown you that what I've done here is the correct answer. So what I'm telling you right now is that this black one, let's just get the value of it. That's the value. And the red one, let's just get the value, is 5. So what I'm showing you now is that if I divide this ratio by this one, the answer will be 5 divided by that. So it will be 5 divided by LL. Okay, that's the answer. And how can I check that? Well, it turns out that what I'm doing here is I'm actually dividing 5/8 by 4/10. You don't know that. But if we do that, what do we get? Okay, let's see. 5/8 times 10 over 4, okay, which means we're going to get 50 over 32, okay? What is 50 over 32? Okay, it's pretty close, right? Because I'm dealing with the segments here. So now that's how we would do division, okay? Multiplication is slightly different because we measure with the reciprocal. In other words, we measure with switching on the second ratio the antecedent and the consequent. That's the reciprocal. Okay, so let's get rid of these. Let's get rid of these. Delete here and delete here. Delete this and take that out, and we can also delete this and get rid of that. Okay, and that. Okay. So if we're going to multiply these two ratios, we need to switch these two around, like that. Go like that, and like that. Okay, so in essence now, what we're going to do is we're going to be multiplying 5/8 by 4/10, and we should get a quarter, right? So let's again do the same thing. Let's, I think the easiest would be to make this consequent the same as this one. So let's connect this line now, like that. Put another point out here, like that. Get another parallel line, like that. And then move this down here like that, and then connect those like so. Okay, and now what we'd have to do is find this length, right? Which is that segment. So this segment is 2.5, okay? This guy here is 2.5. My goodness, I'm going to rename it as PP. Okay, so this segment here is PP, and the multiplication will be the ratio of PP to this orange one. Oops, didn't mean to do that. The multiplication of the ratio of PP to this magenta one. So let's just get the value of PP. So the value of PP is 2.5, and this value is 10. And if we've done the right thing, 2.5 divided by 10 should be a quarter, right? 2.5 divided by 10. Okay, so we've multiplied, it's correct. So we've multiplied this ratio by this ratio, okay? That's what we've done, all right? So now the next question you'll ask me is, how do we find a common consequent? Well, let's see how. Let's get rid of this first. How do we find a common consequent? Well, when we have them both expressed through parallel lines using a common consequent, then to find a common divisor is very easy, okay? So we did find that, just make sure this is right, and this is right. Okay, so to make sure that they have the same common divisor, we would take 10 and 2.5. All right, so let's do that. So segment 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. By the way, I don't have to count here. I'm not counting because I just take this guy here, the whole magenta one, and I turn it on the side. Okay, let's make sure it is that value. Yeah, it's good. Okay. No label. Right. So now we have that, and then we get this little guy here, which is 2.5. And just to be on the safe side, let's go there, and let's say, okay. Now what we do is let's get this guy out of the way. Right out of the way. Don't need him anymore. Like that. Now we're going to find a common consequent. I mean, not a common consequent. We've already found a common consequent. We're going to be finding a common divisor of these two lines because the new ratio is this. See? That's the new ratio. Ta-da! That's the new ratio. Now, because we don't want to deal with lines anymore, we want to deal with numbers, we need to find a common divisor so that we can give names to these line segments. How do we do that? Okay, this is how we do it. So we come down here like that, and then we say, let's get the difference here. So it's not hard to do if we do this. Let's just see what point is that. That's m. So we'll say x is equal to x of m, like that. And take that point, and then this length here, from this point to this point, is the new segment we're going to be dealing with. Let's see what it comes to. That's 7.5, okay? So down here, we need a segment of 7.5. God damn it. Okay, segment 0.5. So we go like that, and we say 7.5. All right, and then we do the same story again. We take the difference of this short one and this one, which is this guy here, right? So we're finding a common divisor. This is Euclid's algorithm, people. So here's the common divisor. Not that one, this one. Okay, so that one's 5. So the next one is going to be easy to do. It's just taking a line segment, and it's 1, 2, 3, 4, 5. It's that, okay? And then the next difference is going to be this guy here, isn't it? So this point here is r. So x is equal to xr, and basically get that difference. I'm doing all this so you can see I'm not using numbers at all, right? Get the segment, okay, like that, and that's 2.5, no problem. I could actually just grab that segment and put it down here, right? Just hang on a second. So now we go here and we go 2.5, like that. Okay, now, and then of course the difference between this 2.5 is again 2.5, so we'd have another segment here, which is 2.5, and now we stop because that's the common divisor, isn't it? Okay, so now this here measures that, so we stop, and it also measures that, and it also measures that, okay, and that, and this. All right? So now we can count. Now we can count. Let's get rid of that. Now we can count how many we've got, right? So we've got how many of these? We've got let's see here, we've got 1, 2, 3, 4. And actually I wrote that the other way around. It should have been written like that, with 10 like that, and this guy over here. Right, so now we've got 10 of the 4 of those, if that's 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Made it a little bit too long, doesn't matter. So it's 1, 2, 3, 4, and it's 1. So now we can actually name this ratio here, okay? We can name this. Let's get rid of that, delete. We can name this ratio. We can say, that's 1, and that's 4. So what we've essentially done is we've taken the product of this ratio with this one. Okay, we've taken the product of this ratio with this one. And of course, this ratio here, my friends, happens to be 5/8. If you don't believe me, you can count them. 1, 2, 3, 4, 5, and 8. And this here happens to be 4/10. Okay, as you can see, 10 there. And of course, 5/8 times times 4 tenths gives us what? Gives us 1/4, which is what we got. This whole contraption here. Okay. So in algebra, what happens is we move away from line segments. We find a common unit or divisor. Its type and size do not matter. It can be any type and size. That's why normally we say 1 meter or 1 unit or 1 inch because we don't know, okay? Because we don't know, right? Cross that out. All right. So I think I've done everything right. I do have an old brain. It's possible for me to make mistakes. But if you just think about these things carefully, you'll know what I'm talking about. So look, I hope I've been able to explain this to you properly. But don't worry because in my article called Gabriel Arithmetic Without Numbers, I explain these things to you and you can understand them. So if you're not already a subscriber to my channel, become a subscriber. It costs you nothing and it helps me a heck of a lot. I'm a poor guy. Okay. I struggle to make ends meet. Many times I don't and I go without. Just think about that. I'm the most brilliant mathematician and I still have to go without. Isn't that incredible? While all those fat, fraudulent PhD cats who are sitting on Abel Prize committees and Fields Medals committees are awarding themselves and their huge anuses millions of dollars in prizes. They're disgusting, vile, dishonest creatures who are taking your money, placing you into debt to hundreds of thousands of dollars, and you don't understand shit when you leave with your PhD. How can you understand when you don't even know these basic things, people? How can you? You can't. Okay. Now, if you want to support me besides becoming a subscriber, you can join my members only channel. Sometimes I share information there which I've never shared before. Sometimes. And that would cost you $4.99 a month, let's say €5 a month, which is price of a cup of coffee for the great John Gabriel. If you're not already a follower on academia, follow me on academia. You'll learn a lot from me, more than you've ever learned from anybody else. Because yes, I do know better. And trust me, uh, Chinese people, Chinese parents who are much smarter than most parents in the world. I hate to say this, but they are. And they support teachers. It's not like the US where you get treated like you're less than shark shit. You get paid a salary on which you can survive, just slightly higher than minimum wage salary. And there are teachers who are getting over 100,000 and they should have been booted out even before they stepped into a classroom. I'm thinking of the teachers in the math department, for example, at Port Angeles High School. They are the biggest bunch of fucking morons I have come across in my entire life. Believe it or not, every single one of them are getting over 100,000 a year. There was one who was a language teacher first, who I don't think works anymore, but I need to say this. He spent a whole lesson showing students how that when you have f of x is equal to 3x5 minus 4, and you put 0 in x, he did this for so many different equations that's the answer. Okay. I mean, 45 minutes he did this. And of course, the little dimwits stood on their table when they did the Oath of Allegiance and they issued a Nazi salute. And when I reported this to the AmeriCorps uh, manager, she didn't believe me. Well, that's the state of American education right now. It's pitiful. It's in shackles. It's going down the toilet faster than the speed of light. Shameful. Anyway, I'm the great John Gable, and this is a new calculus channel. Check out the articles in the details section. You'll become wise. Till next time, my friends, goodbye. Oh, and don't stop loving me.